like Justin said, my name is Steve Bussey. I'm a staff software architect at SalesLoft in Atlanta. My GitHub, I just kept my college GitHub ever since then, so it's SB8244. The numbers are completely random. So a bit about me, I've spent the last 5 years at SalesLoft, watching the company grow from 10 employees up to 360 employees now, and everything that comes with that. It's been really awesome. Primarily writing Ruby and React, used to write a lot of Angular, more React, but now actually for the past 2.5 years I've been working primarily in Elixir, and of course still doing some Ruby things, but a lot more Elixir time right now. And I would say like at this point that we have successfully introduced Elixir into the SalesLoft engineering organization. So that's what we're going to talk about today. And real quick, the little promotion for SalesLoft. Really excellent company and engineering culture, and sort of the proof of that is #1 best place to work in Atlanta for the past 2 years. We just got that last week again. And we've been using Elixir in production for about 2.5 years. And at this point in time, we have about a 30-person back-end engineering team, and about half of the team or more seems to be working almost exclusively in Elixir, which is pretty neat. Today's talk is going to be looking at the different parts of taking Elixir into production, and that's going to focus on the human side as much as the technical side. I think we spend a lot of time looking at the technical side of bringing in a language, but speaking from experience, so much more of the human side that has to go into it. This is not going to be how-to focused. This isn't how to stand up Elixir in production, like how to deploy it or anything like that. This is much more ideas, and if you're someone who's been thinking about this and has been thinking about how to introduce Elixir into your organization, this talk will sort of be tailored towards you. And I think most likely we'll have time for questions at the end, so if you hear anything that you want to ask more questions on, definitely think about that and save it for the end. So let's get rolling here. So this is an important thing to remember. Everybody starts from the beginning. Chris McCord starts from the beginning, Jose starts from the beginning. Everybody does. And that inevitably means that if you haven't started yet, you're going to have to go through that and start at the beginning. And a lot of times that's going to involve, once the language is around, vetting the language, doing things self-taught. Maybe you're just exploring, seeing how things are working. Maybe you have a support network of people that already know the language that can help you out. But maybe let's say very self-taught exploration. Maybe you have best practices, maybe not, because there's, things are self-taught at this point, and you're still working through what those best practices might be. But it's fun. Elixir, I remember learning it, spending many months just trying to digest and get into this new paradigm. And while at the beginning I wasn't very good at it, I was still having a lot of fun with it and knew it was promising and something I wanted to keep going with. And things got to the point of moving smoothly. And finally, you have the conversation with your boss or your CTO or someone at the company that maybe has some authority to sort of help spearhead a project like this. And you ask, can we introduce Elixir as a language in our stack? And hopefully you get maybe a simple answer that's like, yes, but what about ... And this sort of is about the whatabouts of this type of process. And I was lucky to have a very supportive CTO that saw the benefits of what we were proposing with Elixir and was very much supportive, where we didn't get a no at first. We actually did get a yes, but what about? So what about getting the team on board with Elixir? So these are some questions that I would very commonly hear from the team, and actually maybe even still hear from the team, because not everyone has adopted Elixir yet. So this process, for me, is still going on 2.5 years after the initial introduction. How will Elixir or Language X, how will Elixir and Language X transition work for my day-to-day? So let's say for SalesLoft, we were working in Ruby. So how is the transition from Elixir to Ruby going to affect my day-to-day work as an engineer? And it's really important to set these clear expectations up front with how Elixir will impact day-to-day. So that means thinking about this and having an idea of what that will be. So will things slow down up front? Will they ever get back to normal where I'm back up to the full 100% capabilities of myself as an engineer? And my answer to this, and what I've seen, is that things will be slower initially. You're working out a lot of understandings of the language and how things will work. But for Elixir, at least, the language is quick to pick up. And by following well-established patterns and best practices, it's easy to, it's not easy, but that's the easiest way to ramp up the quickest. How will I be mentored while learning? So having an in-person consultation, basically, available for any of these hang-ups is so important. I know, and there's a lot of distributed companies now, so maybe let's say a face-to-face over some type of video conferencing software that you use. But basically having someone that you can go to and directly ask these quick questions and have a synchronous conversation with. And I would say there's usually going to be 1 to 2 champions that are really driving a language adoption project home. And these will be people that are willing to take on the full burden of that project and can be interrupted to help out. So that means that they might be working on something that is unrelated to introducing the language, and someone hits a snag and is preventing them or their team from moving forward. And now these champions have to be willing to say, I'm willing to give up my time and be interruptible to help you and your team get through this blocker. And then also finding helpers throughout this process. So I sort of define this as people that are willing and have the understanding to field questions in maybe a public Slack or in person, and they're less likely to be interrupted. So if they're in the middle of something, you're not going to go to them and say, hey, I'm blocked on this, but maybe you post that in a Slack channel and they would be looking for it. And one thing that I would do for this, sort of as one of the champions of bringing this in at the company, is people that I knew the answer to a question, I might ping them and say, hey, could you take a look at this and help this person out with their question? To basically sort of try to get the information spread out throughout the company rather than just coming from one person. And I think that helped a lot. When would I use this over my current language, so Ruby? And this is something that I get this question probably once a month still. So having clear goals of what you want to achieve with Elixir is important. Do you want full replacement, sort of mandate style? Or do you want to have a choice for the engineers and the act of introducing Elixir only to have another tool in the tool belt? And have a few compelling reasons based on your particular business case. I think it's hard to say, here's some generic reasons why you should do this. I think it's going to be very tailored to how your team works, how your product works, and different challenges that you face. But definitely be prepared ahead of time, because I do think that it does not instill confidence if someone goes to the person that is supposed to be spearheading an initiative like this and asks, why should I use this or when should I use this? And the answer is, I don't really know, let me come back to you. Maybe indicates that that's something that's really important and needs to be thought out ahead of time. How will I be able to switch between Language X and Elixir? So consistency across code bases may be one way to help engineers between working in the old and new code bases. So we did this at SalesLoft via an API framework, for lack of a better term, which is an abstraction over basically any specific controller implementation. So our Rails code, our Ruby code, and our Elixir code for our API endpoints looks very similar. And we use macros and stuff like that to basically get to the point where you can almost copy-paste the sort of metadata of what goes around our API, and it will just work in Ruby or Elixir. And there's a few tweaks you have to make, but it's very recognizable between the two. And so we prioritize consistency between these code bases to make people's lives easier. And that's not necessarily the only way to do it, but that's just one technique that can work well. So you can imagine perhaps that if you were switching between 2 different languages or 2 different code bases that were just completely different, and you're doing that back and forth all day long, that might just be really hard to do. And good practices and automatic enforcement of those to make clear what is expected, I think, is also really useful. That way, the champions or helpers don't find themselves in a position of policing. They're letting the tools do that, but they're informing the tools that can do that of what they want. And establishing critical mass for this adoption and for bringing Elixir into the company. So a Slack channel or whatever you like to use for asking Elixir questions could be really useful. Don't let questions go unanswered long. So like I said, if someone's using Elixir for a project and they haven't really used it before and they're blocked on something, the only thing that may be able to unblock them is someone answering their question. So being able to answer those questions timely and accurately is important. And then encourage the people who are learning to help answer more questions. So sort of try to convert them into helpers to basically gain momentum in the critical mass where people are able to answer each other's questions without going to just one particular person. But ultimately in all of this, I would say the most important thing is the empathy and the care that has to go into a process like this. There will be some people on the team who don't want to or can't understand the different parts of the ecosystem and what adoption might look like. And being patient and understanding to those needs is really important to finally help achieve the organization's mission of adoption. And things may move slower than expected, and so patience really is key there. I guess if you're doing something like more mandate side, where like we want to switch from language X to Elixir, it might be a little bit different, but the empathy and the care that goes into a process like that definitely is important because it's not easy. So I will say that not all Elixir needs to be tackled at once. Do engineers have to learn a new language, a new paradigm, and a new ecosystem all at the same time? So the Elixir language itself being a functional language, that might be a big change for engineers who have only ever worked in an object-oriented language. So they might be trying to bring some of those patterns that they're used to from OO into the FO language. Then you have OTP and process-oriented architecture, which is a new paradigm beyond functional programming. That's sort of something on its own that has to be learned. And I wrote this talk a little while ago. I'll say it is still relatively new, but it's been a little while since I wrote this talk originally. But the Elixir ecosystem is relatively new, but does benefit and inherit from the extensive Erlang ecosystem. And the one thing I'll say here is that I was having a conversation with someone today over lunch, actually, and they were explaining how they are going about doing this in production for their team. And they've been doing it for about a year. And they have a successful application in production that's serving business need. And they weren't really that familiar with OTP concepts. They're finally just getting into GenServer and those types of concepts. And that's because you have frameworks like Phoenix, or maybe you're using a job processing system like XQ that are able to provide abstractions, really good abstractions, over those GenServer concepts in such a way that you benefit from the OTP paradigm, but you don't have to necessarily know it. And then as you find yourself needing these features or needing the power of OTP, then you can sort of reach down into it. That's one way to approach it. How are we able to measure the health of the ecosystem? So there's a variety of companies now that are paving the path with thought leadership and community help. Just look at the conference, look around. There's lots of great companies doing this. There's an active Slack community that has 23,000 members and a ton of channels to answer questions. So if you're not part of that, the Elixir Lang Slack group is really useful. The core libraries are well maintained and active. That's great to see. Smaller libraries can become unmaintained, like any language, but I've personally seen great ownership in the past year for libraries that we use. And so I haven't had to go through this falling out of maintenance when I needed it most. And the ease of use of upgrading framework and language versions has, in my experience so far, has been really great, really easy to do those upgrades. So as I mentioned a little bit about Elixir the language versus the OTP paradigm, you can learn Elixir the language separate from OTP. You can utilize frameworks like Phoenix or XQ to introduce systems to production that don't really require the engineers knowing about OTP to develop those systems. And that may not necessarily be the best practice. I won't say that it is the best practice, but I think that is a quicker way to get teammates on board and authoring code. That's actually something that happened at SalesLoft completely organically, as the team wanted to use Elixir, but they wanted to move faster than going through and learning the entire ecosystem in one shot. And so they used Phoenix and they used XQ to build this system. And now they're building new systems that are based on more foundational OTP paradigms and sort of building them the way that they would want to build the application. And that's something that they've been able to do over the past year by learning new things and seeing what works and doesn't work well for them. Let's look at production versus hobby code. So when you're doing hobby code, maybe there's not a whole lot of requirements that you have outstanding, existing requirements. But in a real company with a product, there is existing tech stack, conventions, and baggage that comes with it. And that's not necessarily a bad word or meant to be bad. That's just sort of true that a existing product has baggage that goes with it. And all of the tools that you use or may not even know exist have to be integrated into Elixir and work in this new language that you're trying to adopt. And that may not be easy depending on the popularity of the tools that you use. So looking at monitoring and logging is really important. How can we know if things are working well or not? Now New Relic has APM, open source APM for monitoring Elixir. And I'm really excited about this project in particular because I think it's going to be, it's already great, but it's going to be even better over time with really bringing some monitoring into the Elixir ecosystem. But then also there's these, looking at logging in a traditional app where you just basically have a stack. You go down the stack, you finally get to what you need, you go back up the stack. But with OTP and processes and all that, it's very much more, there's maybe 100 stacks in your one request, and you go down a stack and then you have a simultaneous process that's going through. And that's sort of difficult to reason about mentally, but you have to navigate those parallel processes executing and possibly contributing to errors in production. Luckily, the logging support is simple to integrate using the built-in logger module and your favorite log aggregator. So what we use, we just write the standard out and it just works great for us. So that's been really useful. And we use that a lot, way more than we do in our existing Ruby apps, where we'll just log out something to sort of help the team, if they run into a problem, sort of see what happened in a particular request. So instruments and friends. We used to use Xometer, but I found this library recently that I really like called instruments. So the standard installation for me includes different memory stats like the atom size, binary size, ETS, process, total memory of the system, and then the run queue size, and a variety of other stats also. And I put these, emit these out over statsd and log them in Datadog and create charts for my service. And it's cool because you can configure a tool like this to use just custom metrics that you want to log out. And it's just like the traditional module function attributes of that to basically configure that. And so I couldn't really get a short link the way I wanted to, but I have a blog post that's fairly recent that starts with Elixir probes on stephenbussey.com. And I give basically my instrument setup on that of how I basically just copy paste that anytime I'm building a new app. And another thing to think about is how you're going to report errors. So tools like Bugsnag, which is what we use, have pretty decent integrations now. And I think one of the reasons for that is the Erlang SASL logging, which is the system architecture support libraries. And that allows you and libraries that you use to hook into a system-wide error logger for any errors that occur in any process. Might be a little hard to see on the screen, but basically the whole point of this is that in like 30 lines of code, you can have error interception across the whole system, which is pretty neat. Because of SASL and because of this pluggable system that Erlang brings with it. And this is the Bugsnag Elixir sort of code written by Jared Norman. So this is another thing to think about that I think I didn't really know too much of when I first started, and something I had to learn the harder way is, what happens if my application fails to boot because something is invalid or something is down? And we often tout how well Elixir is suited to handle errors by restarting supervisors in your process trees. But one thing that bit me a few times is that if you have too many crashes too quickly, basically your system will go down and then come back up if you have maybe some monitoring in place to bring it back up. But that's something that I might have a service down and I'd have to deal with. If that service goes down, can my app boot? And an important thing that I learned there is simulate failures in your development and QA environment to see how well your system will operate when processes just randomly crash or can't start. I really like using the observer to basically list out all my processes, and then I just pick a process, let's say that's part of my application. I just kill it or kill the supervisor and just see what happens. And basically I'm trying to build that into the development process of crashes will happen, and I need to make sure that my system will work properly when that occurs. So let's talk a little bit about the Erlang and Elixir internals. And there's a fantastic blog post called Erlang Garbage Collection Details and Why It Matters, which I love and recommend to everyone. And basically, it talks about the structure of a Erlang process. So each process in Erlang contains its own stack and private heap, as well as some other things. And processes can share large binaries in a shared heap. And we'll see a picture of this up next. Basically, large in the Erlang world is defined as 64 bytes, or I think it's above 64 bytes. I'm not sure if it's greater than or equal to or not. But it's the 64 bytes sort of that limit. And then there's two types of garbage collection. There's a short delay generational garbage collection, and then a full sweep, which is a major delay garbage collection. And one of the things I really like is that because you have this, this generational garbage collection alongside the full sweep, is that, and the way it's worked is that garbage collection is per process. So let's say you're in a language that has a system-wide global garbage collection. When that thing runs, nothing else runs. It's a stop-the-world garbage collector. And that's not the way that the Erlang garbage collector is. So you can actually run garbage collection in one process and not affect any of the other processes, which means that you might feel freer to call the garbage collector when you see the need based on your application that you're developing. And so a quick example showing the process memory layout in the blog post I mentioned by Hamidreza Soleimani is we have some process control block telling information, some metadata about the process. We have a stack and a heap where basically the heap is growing up in the free space towards the stack. And then you basically have these pointers in that heap which point to large binaries. And those binaries are stored in a shared heap that other processes can work with. So if you're passing a binary around your system that's over 64 bytes, that binary, the only thing that's copied around is basically like a pointer to the binary. The proc bin is what it's called. So that's copied around rather than copying around, say, your whole one megabyte binary around the whole system. So let's look a little bit about how does Erlang and Elixir scale. And the Erlang VM beam scales across CPU nodes just out of the box. That's just the way it behaves out of the box. And each process in this executes code sequentially. So a process has a mailbox and takes one thing from the mailbox, processes that one thing, then goes to the next item in the mailbox and processes that. But the real power here is that processes execute in parallel with each other. So let's say I have an 8-core machine. I could have 8 processes that are all running at the same time. And then also in this sort of scaling conversation is that the beam nodes themselves can be connected and can communicate with each other to create clusters really easily. This is actually one of my favorite things about Erlang and Elixir is that this behavior is just out of the box supported, which means that you can build a cluster for your application and build features on top of that without introducing a bunch of technology to actually do that. And so as we talk about scalability, and especially around the CPU aspect of scalability, the run queue becomes really important. And also by Hamidreza is Erlang scheduler details and why it matters, which is also a post that I absolutely love. And by default, you can configure this, as you can most things. Each CPU has a scheduler. So if you have 8 CPUs, you would have 8 schedulers. And each scheduler has a queue of messages which are processed sequentially, but parallel to each other. And there's a lot more intricacy to it. This is just sort of the overview. And Erlang is going to prevent CPU-bound tasks from freezing the entire system through a preemptive multitasking. Correct me if I got the wrong one there. Where it can basically interrupt your process, sort of store what it was doing over here, run another process, and then when it decides to, bring you back in and let your process run, and nothing crashes from that. That's just part of what the beam does. And so sort of an example of this is that on the left side, we have our schedulers. We have our n schedulers, and because each scheduler has a run queue, we have n run queues for these schedulers. And then there's migration logic that can sort of make sure that work is balanced out across your system. And this seems very simple, but this is actually one of the beautiful things about how Erlang scales across your CPU just out of the box. And this is one of the reasons why it's able to do that. So we'll talk a little bit here about packaging your application. So one way of doing this, and there's, this is how one team started out. So there's different ways that your teams might do it based on what their needs are, is just the mix route. You start a server in production by running mix phoenix.server if you're running a Phoenix application. And a pro of that is that it's an easy route to get started on. And the code, you can write code that assumes it's run in mix, for better or for worse, but that's what you can do. But a con of that is that you're going to have all of your code on the server. So basically, if you have a .ex file, that .ex file will live on your server. And then it's going to require implementation of some features like remote consoles or different execution tasks that you might have. You have to sort of bring that yourself into the mix, if you will. The route that I personally go on is the Distillery Route. The author of Distillery is here, Bitwalker, Paul. And so this is what I always recommend to people. It's a release packager which turns Elixir source into Beam compiled code. And pro of that is that what you're shipping to production is your Beam output. You're not shipping source code. It ensures that you can ensure that the distribution is ready to start. So the act of spinning up your distribution doesn't require compiling code if maybe something got messed up along the way. There's a ton of out-of-the-box functionality, such as remote consoles, which I think are just really awesome, and that just comes for free with Distillery. You have easy control over the way the VM starts up by specifying a vm.args file and just doing it yourself. And then 2.0, which released a couple months ago, solved a lot of different environment problems that were people were talking a lot about in the community, and had even sort of gone through libraries in the system with some sort of workarounds to the environment problem that people were facing. And 2.0 solves those problems in, I think, a really awesome way. But a con of that, and this is something to think about if you're championing this at your company, is that it is definitely slower to set up at first. I very distinctly remember spending 4 or 5 days just figuring out how to use it and get things working. And I mean like solid 8-hour grind fest sessions of trying to figure out how do I get this stuff set up. It's because I just had never done it before, and the people around me hadn't done it either. And your code can't be reliant on mix. So some of the team that was doing the mix route had actually written code that used like mix.env in their application, and that doesn't work in Distillery, so they would have to change some of their code. And it can also be harder to debug because your code can't be changed. I don't think you should be going into production and changing your source code and then restarting your production app, but maybe in a QA environment, something like that's useful. And that can be a bit difficult whenever your application is basically there's no source code there. It's only the compiled result of that source code. But this is what I would recommend this to anyone if you're looking for the first time to deploy an Elixir application. And I even have done this on Heroku, for example. So it's definitely a versatile solution. One of the things that we also had to struggle with is figuring out how will we pull in private dependencies. As of now, there are mixed private organizations. They're GA now. That wasn't the case whenever we first started this. But we're not using those right now. And we had a challenge of essentially different environments between CI, production, QA, need to pull in these dependencies, and they need to be authenticated to pull in the dependencies. So the solution that I've been using and has been working really well, and we're using it on all of our applications, is using a GitHub access token in CI for basically an organization user, and then locally we just fall back to SSH access, which all developers have set up. And there's an example solution to this on one of my blog posts, but essentially we switch out dynamically based on a system environment variable. If it's present, we use the GitHub access token. If it's not present, we use the traditional Git SSH route, and that requires that you have SSH keys properly set up. So quickly go through some of these different deployment strategies. Heroku or other platforms as a service are actually very easy to get started with and are well documented in the Phoenix documentation. This is something that you can really get started with in like 10 minutes or less, which is awesome. But one problem that a lot of people run into is that the nodes cannot benefit from networking, as Heroku networking is private between nodes. The nodes are isolated. So if you want to have sort of a private network of nodes, you can't do that. Now Phoenix works around that nicely with how their pub sub bindings actually have a Redis implementation, which allows you to not have to have your nodes network for that particular set of features. And then you can't use any type of disk-based tools. at all, like debts, because you don't have a guarantee on Heroku that your disk is going to exist. It'll just be swapped out from underneath you all the time, and so you can't make that assumption. The route that I take at work is using Kubernetes. We have a custom cluster running on AWS, but Google Kubernetes Engine supports running Elixir apps. We did this at a meetup at the Atlanta Elixir meetup of essentially setting up a Google Kubernetes Engine, running Elixir, and then even networking those nodes together. I think we had a working solution in about 2.5 hours, which is pretty cool. And there's potentially a steep learning curve with Kubernetes as these first services are launched. In addition to the 4 days I spent learning how to use Distillery, I spent about another 4 days learning how to deploy to Kubernetes for our particular environment. Once we had that set up now, it's a 15-minute process to get a new service up. But the first time was definitely very difficult, and it's something that you should consider that you'll have to sort of shoulder that burden if you're a champion of bringing this to your company. And then I'd be remiss if I didn't mention sort of the on-metal on a virtual private server, or on just, you're just running it on the Ubuntu or something like that. I personally have the least amount of experience there, but there's a lot of benefits around maybe the performance characteristics of it, and you can use disk-based tools because your disk actually exists, and you can do that for Kubernetes also. It's also one of the easier ways, I would say, to get hot reloads working. That's one of the things people often talk about when they're talking about deploying maybe on metal, is like if they're doing hot reloads. So talking about some node networking right here in Elixir, because I think that this is one of my favorite features, hands down. I have two sort of deep dives into the Erlang networking on my website about, in the Elixir tag sections. But basically, the important thing to note is that nodes can connect with each other through names. And Erlang, once they're connected, is going to handle just automatically managing the health of those nodes and making sure they're connected with things like heartbeats and just a variety of techniques it uses. And by default, you can scale to several hundred nodes out of the box. Let's say 200, something like that. There's some limits because it's essentially a mesh network where just everything talks to everything else. But out of the box, it does support about a couple hundred nodes. And there's other solutions if you find yourself, if you're lucky enough to find yourself in the situation where you need more than that, then there's solutions that can work for that. I use peerage whenever I'm networking my nodes together. Essentially what peerage does for me is it allows nodes to discover each other. For myself, I'm using DNS. So by setting up the nodes and their IPs through DNS, I can have discovery of other nodes. And on Kubernetes, it requires setting up a headless service, which again, the type of thing that you have to work through if you're going through a setup like this. There's also tools such as libcluster that are just as easy to get working. It's really a tool preference choice at some point. And once you have distributed nodes, you can do pretty cool stuff, like you could have in-memory data structures which are kept in sync across your application. One thing that we do is we have essentially a single node choke point, if you will, to reduce requests through our system without locks. You can use Phoenix PubSub for WebSockets, which also has Redis PubSub bindings. You can do other things with it than just WebSockets, but that's one of the common use cases for it. And if you're looking at networking nodes in production, there's some gotchas. One thing that Chris Keithley talked about in his training is that there's no security. There's this cookie, but that's not security. So there is TLS support where you can essentially SSH connect your nodes together and have some security through your SSH, but that's something that you would have to figure out and get set up. And then one of the things you have to think about, as we've seen with the distributed state talks here, is what happens when there's a network failure and my system is partitioned. And that's way outside of the context of this talk, but that's another thing that you have to consider as you're developing systems like this. So now let's finally get into the production results that we've had over the past 2.5 years and the different learnings we've had. So I would say that you can expect general excitement once these patterns are established, because establishing those initial patterns can be really time consuming. And I would not expect a large group to just figure this out. I feel like it's the type of thing where you're really going to have 1 or 2 people that are able to go super deep dive into the technical needs for bringing this into production. But once those patterns are written and the organization is aware of those, I think that's where you start getting the excitement around, hey, I can actually do this. People, the empathy side of things is people feel, hey, I see this happening. I feel like it's something that I can help out with and do. And that's the moment to lean in even further to this type of problem and champion the process to move it forward. So getting excitement isn't the final step. You have to be able to just keep pushing on that so that you build momentum and are making sure that long-term your project is successful. And it's important to remember that not all baggage can be ditched. Certain patterns are going to be non-negotiable. You might have someone that says, this needs to be this way because we have compliance and we have audits, and those are things that we can't put off just because we have this new language, and you have to work through those. So you should be prepared to tackle those pressing issues, even if it slows down your plan at large. You might have to spend, let's say you had to spend months figuring out how to do a bunch of compliance regulations in this new language, but that's sort of the cost of admission if you're bringing this into a company. And this is a great opportunity to focus on the crucial pieces rather than the nice-to-have functionality. So if you say, is this truly necessary and why is that, versus this is just something that we've been doing for the past 5 years. It really gives you a place to do that. And it also gives you a way to have a clean slate for performance. So long-running production apps can make it hard or near impossible to make optimizations. And you can utilize the opportunity of this new language to establish performance as a primary concern from day one so that you don't find yourself in a situation maybe for the second or third time. Background tasks can make your write operations incredibly performant. This is something that's relevant to us because we had one service that was doing just a lot of throughput, like and way more, multiples more than the rest of our system. And we were able to use background tasks on box, and we were okay if some data got lost, to basically have our system respond in sub-millisecond times because of the amount of throughput that was coming through. And deployment will start off painful probably, but I'd say it's stable after it's up. So once you work out the kinks of the deployment strategy that you're using, which I do think you'll encounter some, then you're going to get the stability. And for us, I was asking one of my colleagues here today, have your services had any operational downtime that was not due to just say a code bug? And the answer to that, he said, not since I started. And the same experience for me, I think we've had maybe one or two in the past 2.5 years, which is a better track record than our traditional Rails monolith app that we've had. The biggest takeaway today, wrapping up here. So the one thing to think about is that creating a clear focus for the technical and the human challenges of bringing a new language into production is crucial for the success of this type of project. So thanks. That's my talk, and I'm happy to take any questions.